Hello, fellow hams and YouTubers. Well, what came my way the other day is this Radio Shack HTX-10 10-meter mobile transceiver. I think this was made for Radio Shack by Uniden, probably in the late 80s, early 90s. I'll have to go look that up. It's a 25 watt radio, 25 watts single sideband and FM, and I think 10 watts on AM. Covers the entire 10-meter band. Not very many controls on the front, very easy to use when you were mobile. They didn't overly complicate it. And I haven't powered it on yet, I just hooked it up. I've got at least one issue with it that I'm going to correct, and we're going to take a peek inside as well. But I've got it hooked up to the bench supply and set current limiting to about 500 milliamps. I usually do that when I first power a radio on. I don't want to just hook it right up to a high power source and find out something's wrong, because if the power supply trips into constant current mode, I'll know there's a problem and I'll shut it right off. So here we go. All right, we got a display light. We got static. That's working. So looks like it might be all right. Of course, we'll give it a full test before I put it up for sale. But this radio has a couple of little issues. I'm going to unhook it here. We'll do the actual testing after I'm done going over it and making sure everything's good. It comes with the standard Radio Shack mic. It's got an up and down button on the top. Mobile mounts on the side. And extra holes here where you could put microphone clip. On the back, we've got our antenna, external speaker jack, and there should be a nice power cord with an inline fuse, but this one's been hacked. Look at this mess. We've got electrical tape splices and little ground clips at this end. Big heatsink back here for the finals. Speaker is on the underside of it, and there's a small dent in the case there. It looks like it got dropped at some point. That's not going to hurt anything. We'll open it up and we'll take a look inside, because I'm going to replace this power cord. I've already dug out. I got a good power cord here with a connector on it, inline fuse. So we're going to replace the power cord on this radio, and we're going to have a look inside of it. Let me reposition the camera and we'll pop the case. Okay, so pretty standard case design. The top and the bottom each has 2 screws on each side. The serial number on this one is 2002411. In case you were interested in that. And then the case just lifts off. And we've got a speaker wire. Oh, good, they got a connector on there. And there's our guts. Looks like we got just about everything on one main board. And then, of course, the control, and there's the processor and the digital electronics and everything is on a separate board with, it looks like interconnect pins between the two. And oh, something jumped out at me right away. Uh-oh. Well, I know the radio works, so this is interesting. Let me see if I can get you a shot of this. So, this just leaped right out at me. One of the reasons that I usually open a radio up before I sell it or do anything with it is I want to just give it a visual inspection. And this is one of those times when that was a good thing to do. Right here. See this diode? Here's the lead. Right there, looks like somebody cut this lead on this diode. Now what this is going to be is this is the reverse protection diode. And somebody cut that. I'll bet you when I get my meter out and measure this diode, I'm going to find that it's shorted. I have seen this before. So let's say you've got a radio, okay, and power's coming in, like so, and here's your radio. And when power comes into the radio, the very first thing that it encounters is a reverse protection diode. And then, oh yeah, presumably over here there'd be a fuse. Okay? So what happens here is if you're hooking this radio up and you reverse these connections accidentally, and you hook it up to power backwards, plus down here, minus up here, well, that diode becomes a short to the power and pops the fuse, and it protects the radio so you don't reverse the power into the radio and blow components. This diode has been cut in this radio. I'm going to speculate what happened. I'm going to just imagine what happened here. Somebody hooked this radio up backwards. And when they did, the fuse blew because of the protection diode. So they replaced the fuse, and the fuse blew again. So they didn't think, and they probably bypassed the fuse or shorted it and went to hook up their power and got a big bright spark. And then they took it to somebody who opened it up and found out that they blew this protection diode, that it's a dead short now. And rather than go through the proper thing to do, which would be to replace the diode, he just cut the lead and told them don't hook the power up backwards again. Oh, that's a shortcut, isn't it? Well, I'm going to replace that diode. I'm going to put the radio right, since I have it open to replace this janky power cord anyway. I wonder if it's related to why they, why they cut the fuse off of this power cord and just did this. I don't know. But the radio does come on. Seems like it's going to work okay. So I think what I'm going to do is I'm going to go ahead and take the bottom cover off, desolder this old diode, and verify that it's shorted with the meter. While I'm waiting for the desoldering iron to heat up, I'm visually looking at solder connections on the bottom of the board, because sometimes when these things are wave soldered, some connections don't get very much solder, or in a couple of cases here there's just nothing there at all. And when I go to resolder the points for the power cord, I'll also remake or reflow a few of these solder connections that are iffy. I think that's all of them. The rest of them, there's not that many on this board. I just take a magic marker and I just put a little dot next to each one of them to make it easy to find them again once I've got the soldering iron heated up and I'm ready to resolder. Yeah, those all look good. On this front board over here, those are not header pins connecting the two boards. They actually soldered. It's the two boards just butt up against each other, and in that corner there they just flow some solder. So those were actually hand soldered. I wish they'd spent a little bit of money on connectors. It would have been nice, because then you could have easily pulled this board out. But as it is, you'd have to desolder all of those and then resolder them again to take the board out. Fortunately, the radio looks like it works, so I'm not going to have to do that. So. Okay. Now you can see diode goes there, power leads go there. We've got nice open holes. Now this is the reverse protection diode, a 1N5401. Yeah, it's shorted. It is definitely shorted. So that's what happened. Somebody bypassed the fuse and shorted the reverse protection diode, which did exactly what it was supposed to do. Protected the radio, which is good. All right, we have a new power cord with a connector and a fuse, and the reverse protection diode has been replaced right there. Hopefully you can see it right there hiding behind this capacitor. And as I mentioned, the old diode was indeed shorted, so as I suspected, somebody reversed the power, popped the fuse, bypassed the fuse, and shorted the diode. But fortunately the diode did exactly what it was supposed to do and protected the radio. So let's button it all back up, and we'll hook it up to the dummy load and we'll see what kind of power we're getting out of it. All right, we got the radio all back together, hooked up to power. I've got the SWR meter in line with the dummy load, so we're ready to test it out. Now, I noticed something that would be a gotcha on these radios. You notice I don't have the mic hooked up, or power. Plug it into power. All right, so we got the radio turned on. Squelch is open, but do you hear any audio? I don't hear any audio. If you don't have a mic hooked up to this thing, you don't get any audio out of the speaker. So that kind of threw me off, had me taking the case back apart and checking to make sure I hooked the speaker up, and I discovered that no, it's the microphone has to be hooked up. There, now we got audio. So we're set to 28.200 upper sideband. I've got my little Grundig radio here. I'm sure you can hear that. Got a little buzz. I think it's my fluorescent light. Yeah. Hello, hello. 1, 2, 3, 4. 1, 2, 3, 4. Testing KB9RLW. That's good. So we've got a good radio. She's putting out full power, full 25 watts on sideband, actually closer to 30. On AM mode, AM, and that's about 17 watts. Carrier, 15 watts carrier? Yeah, about 15 watts carrier. And on FM, just shy of 30. Top of the scale is 30. So that's probably 28 watts on FM. So there you are, the Radio Shack HTX-10 10-meter mobile, 25 watt mobile radio. All fixed up, good power cord. Replaced that shorted protection diode, which fortunately did its job and protected the radio. And we've got a good radio. Thanks for watching. I hope you enjoyed the video. If you did, please like the video with a thumbs up. If you're not a subscriber, go ahead and subscribe. Also, join the Facebook page. We can discuss the content of the videos, ask questions, find answers, and hopefully develop a lively community. Thanks again.